Hey, my name is Sensei Poloni, and I'm a mechanical engineer.
Hi, my name is Astella Zhang, and my major is electrical.
Hey, my name is Josh Calabra, and I plan to major in computer science. Our FEDD 2016 project was the Hovercraft. We'll take you through the engineering design cycle and how we utilized that to come up with the final product. In order to design a hovercraft that met the FEDD requirements, we asked ourselves 3 basic questions. The FEDD guide provided to us answered most of our questions. In short, to meet the power requirement, we decided to make the craft battery powered. The design had to be original and could not be pushed or pulled by any team member, and it also had to be completed within a $40 budget, which we stayed under. The course itself was non-carpeted and was 40 linear feet in length and 1.5 feet in width with no turns. So ultimately the aim was to make it to the end of the course without any parts of the craft moving out of bounds. In order to actually hover, a hovercraft must utilize a skirt, which is like a flexible cushion beneath the hull that can channel air. So this meant we would need a source of air angled downwards to direct air into the skirt, and we would also need another source of air at the rear of the design to generate horizontal movement. While brainstorming, we utilized the software Google SketchUp to come up with different designs for our hovercraft. The 2 picture designs are the ones that essentially fuse together to evolve into our final design.
While planning, we gathered all of the material to get a sense of what we were working with. First, we decided to use Styrofoam for the base. It provided a unique, lightweight base that could support more structures such as a model and retain its weight advantage. With this in mind, we knew that we could not use a heavy source of air, so that ruled out many standard ideas such as computer fans. While exploring the engineering resource room in Daniel Hall, we found small motors that could be not added too much mass to our design. We came up with the idea to attach propeller to the shaft of the model. They were light and combined with the model and battery powerful. Also, we knew we need to tailor the propeller specifically to our design. Therefore, we 3D printed our own propeller that left the model just right and were 4 inches end to end. Now we could move to the creation step.
The craft was 12 inches by 6 inches and was rounded at the front. We drilled a 4-inch hole in the middle of the craft that was slightly larger in diameter than our propellers. The underside of the craft was hollowed to decrease the surface area of the hovercraft and to increase the volume of air that could occupy the space between the hull and the skirt, which we'll touch on soon. Next, we used solid foam to mount the first motor above the base of the craft, as the image shows. From here, we used a garbage bag to create the skirt of the hovercraft, which had to provide enough airflow below it so that it would hover. Lastly, we glued the motor to 2 solid foam sticks and placed it in the middle of the craft, directing air to the skirt to provide lift. Ultimately, we opted to use a single 9-volt battery connected to the engines that had a parallel connection between them so that both engines would get the voltage we needed.
Throughout the process, of course, we had many ideas that unfortunately did not quite pan out. The first one was kind of like our original prototype, where we had the fan in the back, at the extreme back, and we had some sort of like battery case in front of it, but that didn't end up working because there was just too much weight in the back, and the weight distribution was such that the front of the hovercraft lifted, but the back just wouldn't lift. And the second design, we kind of tried to control the airflow under the hull, so we created like these 2 foam rods to kind of direct the air downwards, but that ended up working against us because air could not circulate through the entire skirt, so there was no lift at all.
Our first challenge was to design a hollow base for our hovercraft. Our second challenge was the materials. We had to choose the lightest materials possible. The third one was to select the motors. We needed to select the motors that were light yet powerful enough to power the hovercraft. The fourth was to choose the propellers. We had multiple designs for the propellers, so we tried to find the one that was simplest and the higher efficiency possible. Fifth, the skirt. We needed a way to control the airflow and ensure that too much air did not escape through the random parts of the craft.
If we had to do this project over, we would definitely try experimenting with more voltage/current. Our present design utilized 9 voltage. When we tried 18, it did work better. We would also experiment with different shapes and sizes. We were kind of content with the rounded front that we had in our present design, but we would have tried to make it bigger or potentially smaller to see how that would have made a difference. Additionally, we would have tried to make a more efficient skirt. I think one thing that could have potentially worked is kind of gluing or tacking the skirt to the bottom of the hull so that air doesn't seep in kind of like through the sides and through random places of the hovercraft, because that caused us to essentially lose air.
So my advice is for you guys to keep in touch with your advisor, your engineering gurus, so that you can show your designs and your ideas and they can tell you if it makes sense.
I hope you guys can go to the craft center, because craft center is a good place for you guys to work with, and there has so many materials you can use, and also the Daniel Hall is a good place for you guys to find all resources so that you don't need to buy for yourself.
Well, my advice is you can't spell engineer without engine. That basically means start early, don't be afraid to mess around, make a few prototypes, and be open to new ideas.